Today we are playing around with passphrases, building out multiplication tables, dashatizing odd numbered digits inside numbers, we are building out pyramid arrays, we are abbreviating very long words, and finally we build out a PaginationHelper. Hello world, and this is versus Codewars. And I certainly hope you are having a wonderful day today. We begin today with the warm-up segment, a series of easier katas in order to prepare for the more difficult katas later in the episode, starting with a game of rock, paper, scissors. Given two strings, either rock, paper, or scissors, the goal of this kata is to determine which player won. Let's go ahead and get started here. We have const RPS, and we have player 1, and we have player 2. And what we'll go ahead and do, we're going to use an object to map one entity to the winning entity here, so to say. And what we'll do here, const win, and what we'll do, we'll set up an object here. We know rock breaks scissors. We know scissors cuts paper. And we know that paper covers rock. Alright, what we'll go ahead and do with that here. If win at P1 is equal to P2, so to say, if player 1 submitted rock, we will look up rock in our object here, and we know that it's scissors. And if player 2 guessed scissors here, then we know that player 1 is the winner, in which case we return player 1 won. Alright, otherwise, if win at player 2 is equal to player 1. If, for example, player 2 guessed rock and player 1 guessed scissors, then we know player 2 won here. So return player 2 won. Otherwise, I think we know that it's a draw here. So let's go ahead and test this out, shall we? We have some example calls here in our kata instructions here. I'm going to copy this over, and I'm going to do a little bit of a syntax here. This needs to be else if. Anyway, let's go ahead and console.log here. Our call to RPS, passing in scissors for player 1 and paper for player 2. Now, we know scissors cuts paper, so we can expect to see player 1 won returned here. Let's go ahead and test this out and see what this looks like here. Node warmup RPS. And we do in fact see player 1 won. Let's try another call here. Scissors and rock. Now we know player 2 is going to win this one here, and player 2 does in fact win here. What about rock and rock? That is a draw right here. Alright, let's go ahead and punch this into Codewars and see what this looks like. Run the tests. And we are good on that. Our second warm-up kata today, we are determining if employees get a bonus added to their salary. Let's go ahead and read this here. It's bonus time in the big city. The fat cats are rubbing their paws in anticipation. But who is going to make the most money? The goal of this kata is to build a function that takes two arguments, a salary and a bonus. Salary will be an integer and bonus a boolean. If bonus is set to true, their salary should be multiplied by 10. If bonus is false, the salary itself should be returned unmultiplied. Let's go ahead and give this a try here. Const bonus time. And what we'll go ahead and do, return in a template literal this Unicode character first, because for some reason the Kata solution expects this money to return here in British pounds, as seen here. And then what we'll go ahead and do is, in a placeholder here, we'll do check to see if bonus is equal to true. Then what we'll go ahead and do, take our salary, multiply that by 10, and return that. Otherwise, just return our salary. Alright, let's go ahead and test this out here. Bonus time. Console.log. Bonus time. Pass in 10,000 and set our bonus to true here. Let's punch this into Node and see what this looks like here. Save that here. Node, warm up bonus. We get 100,000 pounds here. And that is what our Kata solution expects here. Let's punch this into Codewars and see what that looks like. And we are good on that. Our next warm-up Kata, we are looking for a stray number. We're given an odd length array of integers in which all of them are the same except for one single number. The goal of this Kata is to find that single number and return it. And what we'll do, const stray, we have our numbers array here. And what we'll go ahead and do is numbers dot find. We'll pass in our number to our predicate function here. And what we'll do is numbers dot index of number is equal to numbers dot last index of number. Because in so doing, we check to see if in so doing here, by checking to see if the index of the given number is the same as the last index of the given number, we know that it's the odd number out. Let's go ahead and punch this into Codewars and see what that looks like. And we are good on that. Our next warm-up Kata, we are sorting an array by their string lengths. The goal of this Kata is to write a function that takes an array of strings as an argument and returns a sorted array containing the same strings ordered from shortest to longest. Let's go ahead and give this one a try here. Const sort by length. We have our strings here as an argument. And what we'll go ahead and do, we'll take our strings and run that through the sort method. We have our A and our B and our predicate function here. I think we're going to be returning this in ascending order by their length. And we'll do that, I think, by A.length minus B.length. Let's go ahead and test that out and see we have that right here. Let's take this array right here, copy that over. Console.log sort by length. We'll pass in this array right here. Let's test this out in Node and see what that looks like. Warm up strlen. And we have eyes, glasses, monocles, and telescopes here. Exactly what we were looking for. Let's go ahead and feed this Kata solution into Codewars and see what that looks like. And we are good on that. Finally, we are looking for the largest 5-digit number in a series. Consider this 10-digit number right here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. Or 1,234,567,890. The number 67,890 is the greatest sequence of the 5 consecutive digits in this number here. The goal of this Kata is to return the greatest sequence of 5 consecutive digits found within the number given. The number will be passed in as a string of only digits, and it should return a 5-digit integer. The number passed in may be as large as 1,000 digits. Let's go ahead and give this one a try here. Const solution. We have our digits here. which the Kata instruction state will be passed in as a string. Alright, what we'll go ahead and do, we're going to go ahead and take the string and split it into its digits. Its individual characters here. And what we'll do, const unique chars, rather unique digits equals, and we're going to convert that resulting array into a set. In a JavaScript set, there will only be unique elements therein. And we'll pass into its constructor here, digits.split with a blank string separator here. This ensures that there are only unique elements in that array here. Let's go ahead and console.log that and see what that looks like here. And what we'll go ahead and do down here, console.log solution. We're going to pass in that large number here. All right, we're going to go ahead and run that through node, warm up large consecutive, and we have an error here. Digits.split is not a function. Because this needs to be a string, not a number. Like I just said before. And, well, this wouldn't necessarily be a good enough illustration of that, given the string that we passed in is only unique digits. How about this astronomically large number here? Copy that. Take my. Here's a big number if ever there was one. Let's go ahead and feed this into our little solution here. Look at the size of that. It's a beast. Let's go ahead and try this one. Node warm up large consecutive. And as you can see, this very large number is broken down into its individual digits and placed into the set here, such that we only have the unique digits in that set. Alright, what we can go ahead and do from here, we can convert that set back into an array by spreading it out into elements of an array. Running that through node, as you can see, we have those digits right here. Now, the goal of this kata is to return the largest sequence of 5 consecutive digits in this astronomically large number. Now, what actually 5 consecutive numbers? Oh, I misread this. Okay. Alright, forget I said any of that. I completely misread the instructions here. I don't think the numbers have to necessarily be unique. So, yeah, let's rethink that here. Alright. We got our digits here. We need to split those digits into individual characters. What I think we'll go ahead and try doing here, I might want to resort to a classical for loop here. Alright, what we'll go ahead and try doing here is for let I equal 0, I is equal digits dot length minus 5, I think, plus I. And what we'll go ahead and do here is const sliced number equals digits dot slice from I to I plus 5 join. I'm just going to go ahead and run that through Node and see what that looks like. See how long it takes, since slice is not a function. Digits. Oh, because this is not an array. This is a string. Doesn't take that long to complete here. What we'll go ahead and do, we'll take that parse int. Let's try that, running that again. Doesn't really take that long at all. That makes me optimistic here. Alright, what we'll go ahead and do, we're going to keep track of a maximum. And what we're going to go do, set that to number.min safe integer. Or rather, we can set that to -1 here. And if our slice number is greater than our maximum, we go ahead and set our maximum to our sliced number here. And then we can return that here. Maximum is not defined. Because I misspelled maximum here. I have 99,890 here. Alright, I think I like where this is going here. It didn't really take all that long at all to complete here. Let's go ahead and feed this into Codewars and see what it looks like. And we have a problem right off the bat here. Failed when max 5 digits is at the end of the number. Okay. Alright, what we'll go ahead and do, 63,450. We'll go ahead and do, we're going to console.log our sliced number. We're going to analyze each of these here. 1,890. That's not right at all.
Okay, that's... So maybe them... Oh, that's strange. 6249. Let's look for that in the number here. 624. Okay, let's... Now we're slicing from I to I plus 5. And I'm scrolling down to the numbers here.
93645. Oh, okay. Set this to +4 instead, -4 instead. Just make sure we get the 63450 here. Alright, let's go ahead and punch this into Codewars and see what that looks like here. Alright, that test passes. Let's go ahead and attempt this. And we are good. That concludes today's warm-up segment. I will see you in the next kata. Everybody knows passphrases. One can choose passphrases from poems, songs, movie names, and so on and so forth. But oftentimes they can be guessed due to common cultural references. You can get your passphrases stronger by different means, like the goal of this kata here. Given a string representing a passphrase in uppercase, the goal of this kata is to do the following. A. We shift each letter in the string by a given integer in a circular shift. B. We replace each digit by its complement to 9. For example, if we had the digit 7, we would replace it with the difference of 9 minus 7, which would be 2. Next, we retain any non-alphanumeric characters, such as punctuation, periods, and the such. We downcase each odd index letter and upcase each even index letter. And then we take the whole result and reverse it. Let's go ahead and give this a try here. First, we go ahead and shift each letter by the given integer in a circular shift. For this, we are going to need the character code of the letter A. Const A code. We'll take the capital A and get the char code at. Alright, what we'll go ahead and do, we're going to go ahead and iterate through each character of our string here. What we're going to go ahead and do, keep track of a result here, set that to a blank string, and in the end we're going to return result.split.reverse.join. So that will be reversed. What we'll go ahead and do, actually, I have another idea we can work with here. No. Yeah, this is what we'll do here. We're going to go ahead and iterate through the characters of our string. Now, we need to determine if this character is either a letter or a number. I think we're going to be playing with some regular expressions here. Const letter regex. We need one to look for capital letters here. And we need one to look for numbers. Alright, what we'll go ahead and do, I think, if char, or rather letter regex dot test on char is equal to true, else if number regex dot test char is equal to true, and finally we have an else case here. Now, if the test method on both of these regular expressions upon this character return false, we go to this else case here, in which case we just go ahead and append our character to our result string here. Alright, what we'll go ahead and do from here, we have our letter regex here. If this character is a letter here, we need to shift it rightward, I believe, or rather up by the given number by our shift parameter here. And for that, we're going to need to get this character's character code. Let char code equals a char.charcode at. And we're going to go ahead and shift it upward by the shift parameter given here. We'll do that by doing this, plus shift. Now, we need to determine if this char code is greater than this char code up here plus 26, which would be the letter Z here. I'm going to go ahead and put up a quick demo here on Node. We're going to do Node. I'm going to pull up the repo here. We're going to get to the character code of the capital A here. And we're going to take that and do string.from char code. We're going to pass all that in here. To get to the capital Z here. And what we'll go ahead and do, now that we know that if char code is greater than A code plus 25. Alright, we're going to go ahead and take that string from, we're going to run string from char code. We're going to pass in 91 here, 90 here, rather. And we get our Z here. So we're going to go ahead and actually store this in another constant here. Z.charcode at. We're going to go ahead and do this Z code. And what I think we'll go ahead and do, we're going to do char code minus equals A code. Or rather, we might need to do this in a while loop. That might be a better idea. Okay, let's go ahead and test that out here. We're going to go ahead and take that resulting string here. Result plus equals string from charcode. Now for our if the character here is a numeric digit here, what we need to do is results plus equals, and in the template string we're going to do parse int char here. We're going to take that and we're going to subtract 9 from that character here. Alright, let's go ahead and test out what we have so far here. Console.log play pass. We're going to pass in the string born in 2015 exclamation point. And we're going to pass in 1 here for our shift. Let's go ahead and test this out in Node and see what that looks like here. Node Passphrases. And we have this string here. Good thus far. No, not good thus far. COSN. No, not good thus far. Right, let's go ahead and just return the result here without any of the reverse stuff here.
C P. Yeah, let's go ahead and console.log this char code here. Oh, that's a little strange here.
Okay, that's a little strange here. Why? Maybe because it's the global flag here in our regular expressions. Yep, that turns out to be the problem here. Alright, anyway, we have our scrambled phrase thus far. CPSO JO7984 exclamation point. Alright, what we'll go ahead and do is keep track of a little bit. We're going to keep track of a counter here. Let counter equals 0. And for each, I think, letter in odd position, yeah, position of the string, it's odd. We're going to increment our counter at the end of each iteration of our for loop here. And then what we'll go ahead and do is we're going to go ahead and keep track of a result character here. Const result char equals string dot from char code. And then what we'll go ahead and do is result plus equals, if counter is an even number, then we will go ahead and uppercase it. Result char.to uppercase. Otherwise, result char.to lowercase. Running that through Node, we get our scrambled string with each even index character uppercase and each odd index character lowercase. Now, finally, in our result string, we need to split that into its individual characters, reverse the resulting array, and then join that back together. We need to reverse the string, essentially. And we have our encoded passphrase here. Let's go ahead and feed this into Codewars and see what that looks like. And we have a problem. What's going on? Oh, it looks like it picked up some Unicode phrases in here.
Why did it pick up some Unicode here? Okay, let's analyze this here. PQ. That's strange. Now let's go ahead and take these here. We can copy this, paste this into our local solution here. At 487. CHQ. P67. PJV. PQ. Okay. Let's console dialog the result, each of the result characters here. Char code at. Okay,
let's do a little bit of debugging here. If result char code at is less than our A code, console.log result char code at. Yep, and we do. Yep, that may be problematic here. Let me pull up the repo again, and let me print out the character code of the capital A. And that is 65.
Maybe. Yep. I'm gonna do the Z code here, actually. Here, it's got a repo here. And nice. That doesn't seem to be the solution either that we're looking for. No, I think it's got to be the A code here. Okay, let's go ahead and console.long each of. Now, the character code of capital A is 65. Maybe instead of this while we do an if statement here. Okay, what we're doing here, we're taking the char code, we're setting that equal to the character, setting that to that character's character code plus the shift that we passed in up here. I'm gonna go ahead and console.log that and see what that looks like here. Run that through node here. Result char is not defined. Yep. Let's go ahead and get rid of this if statement here. We'll go ahead and console.log that shifted character code. And then we're going to go ahead, for the sake of reference, we're going to log to the Z code here, too. Yeah, the Z code is 90. Alright, we got to loop that back, too.
Oh, wait a minute. Okay, we got to loop that back to 65 here. I have an idea. I think instead of subtracting the A code, we subtract 26 then. Okay, I think this is it. Alright, let's go ahead and get rid of this here. And run that through Node again. We're going to compare that with the test here. Q, FT67, GJV, PQ, AP, OQTH, GOCE, COP, CTIAO. I think this is good. Alright, let's go ahead and punch this solution into Codewars and see what that looks like. Save that, and now the test passes. Let's attempt, and we are good. Now here is a puzzler involving the use of characters and character codes. It's always good to know where the character codes of the capital A and the capital Z are at. Although the character code of the capital A turned out to not be needed at the end of the day in the case of this Kata solution. What tripped me up here was I forgot that if the character code shifted upwards was greater than the character code of the capital Z, I could loop back by simply subtracting 26 from that resulting character code, because there are 26 letters in the English alphabet. Given an integer n, the goal of this kata is to return a multiplication table with a size of n by n. Take note of this example that you see here in the kata instructions. We have 1, 2, 3, 2, 4, 6, 3, 6, 9 in a table here, when size is 3. The goal of this kata is to return a two-dimensional array representing that multiplication table right here. Let's go ahead and get started with this here. All right, we'll have a result array here, and that is what will be returned. All right, we're going to go ahead and iterate from 1 to 3 inclusively. And what we'll go ahead and do, we're going to push a new array onto our result here. Actually, we'll go ahead and call this a line here. And at the end of this, we'll go ahead and result.push line. We're going to go ahead and have an inner for loop here. That j equals 1. Or rather, instead of 3, this needs to be size. J is less than or equal to size plus j. And what we'll do in here, we're going to do line.push I times j. All right, let's go ahead and test this out here. Console.log multiplication table. We're going to pass in 3 here. Let's run this through Node and see what that looks like here. Whoops. Node multiplication table. And we have our multiplication table here. 1, 2, 3, 2, 4, 6, and 3, 6, 9. Let's grow this out here. Now, we're probably going to have some big... We can probably expect to have some big integers in our tests here. Let's try 1,000 here. And hope it doesn't time out. Doesn't time out. That's promising. Let's try 1,000,000. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yep, that's no good. Let's just hope we don't run into that issue in our tests here. Let's go ahead and feed this into Codewars and see what that looks like. Run these tests. And that passes. Let's hit attempt. And it turns out we don't run into big integers like 1,000,000. We are good. I don't have anything to say about this one, so instead of a Kata reflection, let me plug something nice to you before we get on to the next Kata. Are you a Kata author on Codewars and want to share your authored Katas with me? Drop a link to those Katas in the comments section below, and there's a chance you might see me solve those Katas on a future episode of Versus Codewars. Currently, my preferred difficulty range is between 6 and 4 KYU, so send me Katas around that difficulty range and I'll be more likely to solve those on future episodes of Versus Codewars. Given an integer n, the goal of this kata is to place dashes before and after each odd integer therein. Now, there should only be one dash before and one dash after each odd integer here. So, for example, if we had two adjacent odd integers here, it would be a dash the first integer, dash the second integer, and then dash, and so on and so forth. If n is negative, then the negative sign needs to be removed. If n is not an integer, this is going to need to be checked, then a blank string will be returned. Let's go ahead and give this a try here. Alright, first let's go ahead and handle that edge case here. If type of n is not a number, then just go ahead and return a blank string. Alright, what we'll go ahead and do is... Alright, we will be using a regular expression, probably with the replace method here. Alright, we need to do this. Return n.toString. And what we need... First, we need to go ahead and convert n to a string. Const n str equals n.toString. Now, if n, or rather, we need to let n_str be n.toString, because if n is less than 0, then n_str equals n_str.slice1 to get that negative sign out of the way. Alright, what we'll go ahead and do is return n_str.replace. We're going to be using a regular expression here. I think it's... or I think the regular expression we'll be using is optional dash and then the odd digit here, 13579, and then another optional dash here. And I think this needs to go inside of a capture group here, because, all right, and then our replacer function, we have our match inside here as a parameter. Let's go ahead and console.log that at first and see what that looks like. And actually, in our replacer function, we can go ahead and capture our whatever we capture inside this capture group inside our second parameter right here. And we can do that by doing this. All right, let's go ahead and test this out here. Console.log. I think it's Dashatize. And pass in 6815. Or let's make it a little more challenging. Let's have something with plenty of odd numbers here. 5311. Alright, let's go ahead and do no Dashatize. 5, 3, 1, and 1. Alright, that is the contents of our capture group right here. What we'll go ahead and try doing here is return dash p1 dash here. Now that lends to a little bit of a problem here, because we have multiple dashes right here, and we do not want that. Okay, so what I think we'll go ahead and try doing here, maybe we'll capture these dashes in capture groups as well. P2 and P3 here. Let's go ahead and return our match here. Let's go ahead and console.log all these here and see what they look like. And maybe perhaps okay, let's take that. And I don't think that's gonna do here.
Okay, I do not think that is going to do here. So I think we'll go ahead and try doing here. No match here.
Okay, I have a new idea here. All right, we'll have our NSTR. We'll do our replace here. We'll have our initial regular expression at 1, 3, 5, 7, or 9. We have our matcher function right here. And we'll return dash, match, and dash here. Now, this goes ahead and returns this messed up string here with multiple dashes and a leading and trailing dash. We do not want that here, so we'll run this through another replace call here. In this regular expression, we'll look for any instance of a double dash. And we'll replace those with a single dash here. Almost there. Now we just need to get rid of the leading and trailing dashes here. And I think what we'll go ahead and do is do one more call to replace. And I think in this regular expression, we're looking for the leading dash here. Either the leading dash here or the trailing dash here. And I think that'll do. And we'll replace those with blank strings. And lo and behold, we get our 5-3-1-1 right here. Let's try some other tests here. 6815. Yeah, we get 68-1-5. We want that. Our 274. And we get that right here. Now, what about the special case of not a number? And we get NaN. And that is what we want as well. How about another weird case? Minus 28369. 28-3-6-9. And that is what we want to see as well. In hindsight, I think we can actually go ahead and get rid of this because our regular expressions handle that as well. N dot place our str to n.2 string. Running that, we do get the same result right here. So let's go ahead and punch this into Codewars and see what this looks like. And we are good. The dash character is a reserved character in regular expressions that is often used for looking for characters or entities in ranges here. Now, being a reserved character, I would have thought for sure I would have had to escape it with a backslash if I wanted to look for dashes and strings using a regular expression. However, looking at one of the Kata solutions here, it turns out not to be the case. I could just go ahead and use a dash without a backslash if I wanted to look for a dash in a string. Here we are building a pyramid array. Given an integer n, the goal of this kata is to return an array of subarrays of ascending length of length n. The subarrays should be filled with 1s. Let's go ahead and give this a try here. We're going to keep track of our result array here, our top level array here, and this is what's going to be returned. All right, what we're going to go ahead and do is for let I equals 1, I is less than or equal to n plus plus I. And what we'll go ahead and do is result.push new array of length I.fill 1. Let's go ahead and test this out here. Console.log pyramid 3 here, for instance. Node pyramid, and we have our 1, 1, 1, and then 1, 1, 1. All right, let's go ahead and test this out here. Some of our test cases here. How about pyramid 10? Yep. We do have our pyramid arrays here. Let's go ahead and feed this into Codewars and see what that looks like. And we are good. The array objects constructor, in combination with its fill method, is a quick and effective way to quickly create a new array and fill it out with elements, all in one line of code. In the developer community, it's a common practice to abbreviate very long words, like internationalization, into a form such that the first and the last letter of the word encapsulates a number representing the number of remaining letters in the word. That is, the number of letters in the word minus 2. For instance, internationalization becomes I-18N. Given a string, the goal of this kata is to take all of the words in that string which are 4 characters or greater in length and abbreviates them in the fashion aforementioned. Let's go ahead and give this a try here. What I think we'll go ahead and do is, I think we'll go ahead and use a regular expression here. Now, let's have a look at the tests here and see. Yep. Alright, what we'll go ahead and do is, we're going to take the string, and we're going to run it through the replace method here, and we're going to use a regular expression here, looking for any and all white space in that string. Whoops. And we're going to have a replacer function here that turns up all of our matches here. This, I think, looks for all letters, common sequences of letters in our string here. I'm going to go ahead and console.log our match for now and return our match. Let's go ahead and take this test string right here in our kata instructions. I'm going to do console.log, abbreviate. We're going to pass that string in right here. Let's test this out in Node and see what that looks like. And we get our matches here, which are our words we are going to abbreviate. Now, it's actually not enough to just look for any sequence of letters here. In our regular expression, we actually need to look for words that are 4 characters in length or greater. So, and we can do that with the curly braces here. And inside the curly braces, we'll do 4 comma. That tells the regular expression to look for sequences of letters of length 4 or greater. Let's go ahead and run that through Node and see what that looks like. And as you can see, it only matches up the words elephant, rides, and really. Alright, what we'll go ahead and do from here, we need to replace this, we need to abbreviate this into the fashion that we mentioned before here. And we'll do that by doing this. We'll return in a template string the first character in our match, the length of our match and characters, minus 2, and then we need to pull the last character of our match from here. And what I think we'll do, I think it's possible to do something like this. Match at index minus 1. Is it? No. So, actually what we need to do is match.slice minus 1. And as a result, we now have this abbreviated string. It says E6T-R3S elephant rides are really R-E-A-L-L-Y fun R4Y and then fun right here. Alright, let's go ahead and test this out in some other cases here. How about internationalization? I expect to see I-18N if I spell that right here, and we do. Let's go ahead and feed this into Codewars and see what this looks like here. Let's run the tests. And we are good. Although not applicable to the strings that we worked with in this Kata solution here, if it's anything different, please let me know. In newer versions of JavaScript and in Node.js version 16.6 or later, JavaScript's array object will have a new method called @, which, when a negative number is passed in, can be used to reference elements in an array at an index relative to the end of the array rather than the beginning of the array. This is another way of doing this and a more compact way than referencing an element in the array at index array.length minus I, or using the slice method to pull out that specific element of the array. I will be posting a link in the description with more information on the @ method from MDN. For this Kata solution, we are implementing a utility class, which is helpful for querying paging information related to an array. This PaginationHelper class is designed to take in an array of values and an integer indicating how many items will be allowed per each page. The types of values contained within the collection or the array are not relevant. Shown here in the Kata instructions are some of examples of how this class is used. First, we have this constructor right here, which takes two arguments, an array of values and the number of elements per page. And as you can see in this implementation here, we have four helper methods here: item count, page item count, and page index. Now, the page count method should return the number of items in our page. First, let's go ahead and implement our constructor here. Let's go ahead and get started with this. Obviously, we'll have this dot collection equals collection, and this dot items per page equal to items per page. And then what we'll go ahead and do is we're going to have an array here called pages. And what we'll do is first we're going to set this to an empty array here. All right, we're going to go ahead and iterate over the items in our collection here. For let I equals 0, I is less than collection, this dot collection dot length. And we're going to do I is plus equals items per page. And in this for loop here, we're going to go ahead and populate our pages with the items in our collection here. And we'll do that by doing this. This dot pages dot push. And I think we're going to spread out an array here, and this array is going to be this dot collection dot slice I to I plus items per page. All right, let's go ahead and make a new instance of this PaginationHelper here with the constructor shown in our Kata instructions here. Const ph equals new. We're going to go ahead and set that equal to a new PaginationHelper with this array and the items per page shown here. All right, let's go ahead and console.log ph.pages. We're going to run this through Node and see what that looks like. And that is not what we wanted. Yeah, of course that's not what we wanted, because we don't need the spread operation here. So now we have each of the elements of our collection divvied up into pages here. All right. That should help us out a little bit when we're implementing our helper functions here. First, we have our item count here. Now, item count, I think we're okay. According to this the Kata template here, item count returns the number of items within the entire collection, and that can be implemented by doing this. Return this dot collection dot length. Returns the number of items within the entire collection. Now our page count method here returns the number of pages. This is easily implemented by doing this. This dot pages dot length. Now we have our page item count method here. According to our Kata instructions, this method returns the number of items on the current page. Now, the index here passed in is a 0 based, and this method will return -1 if page index is out of range. So what we'll go ahead and do is, if index is less than 0 or index is greater than or equal to this.pages.length, we return -1 here. Otherwise, we can do return this.pages@index.length, because it returns the number of items on that page. And finally, we have the page index method. This determines what page a certain item is on. Alright, again, index is a 0 based, and this method returns -1 if index is out of range. Okay, what we'll go ahead and do is determines what page an item is on. Now, I assume this is probably an index in the collection, correct? Let's go ahead and... Alright, we need to get the item in the collection that is being indexed here. And we'll do that by doing this. Const collection item equals this.collection@index. First, if index is less than 0 or index is greater than or equal to this.collection.length, return -1. Now, this collection item, we need to figure out what page this is going to be on. So what I think we can go ahead and do
we take the index.
Okay, maybe we get the floor of index divided by this dot items per page, and maybe we add 1. No, this is 0. No, I think this is actually 0 based. The index is actually going to be 0 based here. Alright, let's go ahead and test our methods out here. And well, we can go ahead and do that by doing this here. I'm going to copy all of this here and paste it here. I'm going to do some console.log here. And yeah, give me just one moment while I get all this ready here. And likewise, we'll do some more console.logs here. Alright, we're going to run all of this through Node and see what all of this looks like. There's a little bit of a typo here. We're going to run all of this through Node and see what all of this looks like. And we got helper. Yep. Call this helper. Yeah, we get 2 for the page count, 6 for the item count, 4 for page item count with 0 passed in, 2 for page item count with 1 passed in, because that is the last page, a -1 for 2 here. Now, we get 1 for a page index with 5 passed in, 0 for page index with 2 passed in, and -1 each for page index with 20 and -10 passed in. That is what we want for all of these here. So let's go ahead and punch this into Codewars and see what this class implementation looks like. We're going to run our tests. I don't know what's going on here. Should test for something. Yes, there are actually no tests implemented here, so we just go ahead and hit attempt, and we are good. Here is the better code solution of the day. Pay mind to this rather large code snippet you see obstructing my face here. It turns out I really didn't need to divvy up the elements in our collection into separate pages after all. In this implementation, in the page count method, we simply take the ceiling of the collection's length divided by the items per page, or rather, take the collection's length divided by the items per page, take the quotient and round it up to the next integer. And then, in the page item count method, we take the minimum of the items per page and the collection's length minus the page index times the items per page to get the page item count. And that is going to do it for today's episode of Versus Codewars. If you like this video or you learned something new, drop a like and subscribe to this channel to see me take on more coding challenges on Codewars. As always, if you think there's anything I can do to improve on my code for the better, feel free to drop a suggestion in the comments section below. I hope you have a wonderful day, and I will see you on the next episode of Versus Codewars.